We introduce UltraGrasp. Welcome to the future of prosthetic forearm technology.
3 years ago, my aunt had to undergo a life-threatening blood clot, which resulted in the amputation of her forearm. She later received a prosthetic device controlled by electrode sensors, but it caused discomfort and swelling in her skin and was often unresponsive.
Anish's aunt is not alone in experiencing skin discomfort, as over 75% of amputees report the same. The electromyography sensors used to control prosthetics are often faulty, and the lack of ample sensory feedback through haptics limits the patient-prosthetic bond, which affects how skilled amputees are at using their prosthetics. There are 22.3 million people worldwide who require forearm prosthetic limbs, but their high costs ranging from $15,000 to $80,000 makes them inaccessible to most amputees, especially since many amputees are blue-collar workers or in third-world countries. Even those who can afford these devices face challenges, as around 30% of people with limb loss suffer from depression and anxiety due to the stigma surrounding prosthetics, which can lead to decreased self-esteem and discourage their use. Given these challenges, there's a growing need for an alternative in the prosthetic market.
UltraGrasp eliminates the need for invasive EMG sensors and its side effects, including long-term skin discomfort, faulty response, and fatigue from high physical exertion. We also reduced the maintenance required and the price range. We created a novel auto-generative method for grasping. A depth camera in the palm captures images of the target object and inputs them into a residual neural network for feature extraction, providing information about the texture, geometry, and size of the object. The network then generates a 6D grasping pose, later used by PID control and inverse kinematics to control the fingers and wrist, raising patient safety and mobility. This allows for intuitive grasping in clutter, since the software can predict which object the user intends to grasp. The design integrates haptic feedback for improved touch sensation, and Cora, a natural language processing powered virtual assistant that we created, which enables personalized therapy and elderly care through vocal interaction. The arm can also detect potential issues before they become problems, using machine learning, allowing for proactive maintenance and reducing the need for costly repairs. Our product has been reviewed, completed, and promoted by Stanford's NPTL as well as the Medical Center Orthotics and Prosthetics.
The absence of medical-grade sensors and use of 3D printing allow UltraGrasp to maintain a very competitive, near 90% profit margin that has a unit price of $4,999 and manufacturing cost of around $700. Our main components include an Intel camera, Raspberry Pi, and Arduino. With more research and development in our first few years, we plan to create our own components, further boosting our margins.
Moving on to our market, there are about 20 major prosthetic hands that are in commercial use. The most widespread ones are those made by Tasca, Covey Nexus, Ottobock, and Osur. However, these devices all come with their limitations, ranging from low affordability and limited comfort to lack of sensory feedback. As said previously, UltraGrasp also offers computer vision capabilities, a feature none of our competitors have. Osur's forearm artificial limb is the most qualified when compared to other existing technologies, but is unaffordable for most as it is estimated to cost around $80,000 and is not aided by intelligent softwares. UltraGrasp capitalizes on these setbacks of other leading artificial limb companies, giving us a competitive advantage in the market.
Onto the industry. The total market value of the prosthetics and orthotics industry is $6.65 billion, with a projected value of $12.2 billion by 2033. Inside this massive market, our segment is the upper limb prosthetic devices, which is valued at $1.5 billion. Current prosthetic companies like the ones mentioned before target relatively wealthy amputees who can afford high-end prosthetics or have easy access to healthcare services, mainly in the USA, Canada, and Western Europe. The middle class and underprivileged amputees, especially in Asia, Africa, and South America, where the majority of forearm amputees live, have not been targeted in the industry because of the high cost of these advanced forearm limbs, which are inaccessible for most amputees living in these areas. However, because of the extremely affordable cost of UltraGrasp takes advantage of these markets on top of the current market that includes wealthy amputees. UltraGrasp aims to generate revenue through 4 methods: direct hardware sales, software subscriptions, healthcare licensing, and product upgrades. Direct sales offer a base solution to customers. Software subscriptions supply a constant source of income that keeps high customer retainment, since many amputees will be using our product for the rest of their lives. Healthcare licensing involves a 5% royalty on products sold by healthcare companies, and upgrades offer extra hardware revenue. In the upcoming years, our company will provide professionals to assist with fitting the prosthetics and treatment for amputees, and we will offer customer service by providing direct maintenance and addressing any issues or problems with using our prosthetics.
UltraGrasp not only strives to maintain durability, reliability, and comfort, but also maintains hospitality with our voice-activated features and helps amputees grasp more than just objects. Grasp life. UltraGrasp.